Hello and welcome to my channel. I am Mensah Augustine. Please, if you're new here, kindly subscribe to my channel. And if you have been watching my videos and if not yet subscribed, please kindly subscribe for us to build the mathematics community. In this lesson, we are going to look at how to use the laws of limits to evaluate limits, or how to evaluate limits using the properties of limits. Thanks to Elizabeth Asuminiwa for requesting for videos on limits. If you want me to do videos on any lesson for you, kindly leave it at the comment section. Now, let's start. If you have not watched my video on lesson 1, that is the intuitive definition of limits, and lesson 2, that is properties of limits, check the description for that video to improve your understanding. Now let's take our first question. Our first question is that we're going to look at the limit as x approaches to 5 times x. From the properties of limits, we're saying that the limit of a constant multiplied by a function is the constant times the limit of the function. So this is the same as writing the constant 5 times the limit of the function. So here you write 5 times 2. That is equal to 10. So if we take the limit as x approaches minus 4, 3x squared, then is the same as the limit as x approaches minus 4. Bring the constant out as x cubed, and we have 3 times the limit as x approaches negative 4, x all to the power 3. Wow! This is the same as 3 times the limit. Okay, so here we have this, so we can put in minus 4 for x. So we put in minus 4 to the power 3. And what are you going to get? That is 64 times 3. That's minus 4 to the power 3 times 3. That is minus 192. Minus 192. This will give us minus 64 times 3 will give us minus 192. Okay. So let's look at the next question. That is this question 1. This is question 2. So let's go to question 3. Take the limit as x approaches 5, 2x squared minus 2x plus 1. So we take the limit of each term. That is, the limit of a sum is the sum of the limits, and the limit of a difference is the difference of the limits. So here we take the limit as x approaches 5, 2x squared minus the limit as x approaches 5, 2x plus the limit as x approaches 5, 1. So this one, we've done it already here. How to simplify this? The same idea. So this is the same as 2 times the limit as x approaches 5, x, put it in the square. Very simple as that. Minus 2 times the limit as x approaches 5 of x plus the limit as x approaches 5, 1. Wow. This, you've evaluated some here, so go through the same procedure. So this one gives me 2 times 5 squared minus 2 times 5. We know that the limit of a constant is a constant. So the limit of 1 as x approaches 5 is 1. So here we take 2 times 25 minus 10 plus 1. That is 50 minus 10 plus 1, and that is 41. Very good. Now let's take the next example. Let's take example 4. Example 4, we are going to consider the limit as x approaches -1, 3x cubed minus 2x divided by 4x all squared. So here, from the laws of limits, what do? We take the limit as x approaches -1, 3x cubed minus 2x divided by 4x all squared. Very simple as that. And here we evaluate what is inside. So we take the limit as x approaches -1, 3x cubed minus 2x divided by the limit as x approaches -1, 4x all squared. That's the limit of the quotient, is the quotient of the limits. So we take the limit of the numerator and the limit of the denominator separately. Then here we have the limit of the difference, so we take the limit of each term. So we're going to have the limit as x approaches -1, 3x cubed, we've done that one already, so it will be 3x to the power 3 minus 2 times the limit of x as x approaches -1, all divided by 4 times the limit as x approaches -1. Okay, so here we bring the square. So what are we going to get? We are going to have here as 3 times -1 cubed, as if you put -1 for x, minus 2 times -1 divided by 4 times -1. We have squared, so we bring all squared. So this will give us -3 plus 2 divided by -4. That will give us -1 on -4. That is 1 out of 4. Very, very simple as that. So you know that the limit of the quotient is the quotient of the limit. And when you have square, the limit will enter. Then after that, we square the final answer. Yes, so here, I nearly forgot. So there we go 1 out of 16, right? Very, very simple as that, because of the square. Now let's move on to the next example. And I think that is example 5. Here we are going to have this one, that is the limit as x approaches -1 out of 2, then the limit as x approaches 1, xt cubed minus 2xt minus 5t squared. So how do we evaluate this limit? So to evaluate this limit, you evaluate the inner one first. So we take the inner one, the limit as t approaches 1, Here x is a constant, so we bring x out. We take t cube minus the limit of, so here minus, bring 2x out. Then we take the limit of t as x approaches 1 minus 5 times the limit of t squared as x approaches 1 then bring the limit as x approaches negative half. Wow. So we take the limit as x approaches negative half. We have x times 1 keep minus 2x times 1 minus 5 times 1 squared. This will be given as the limit as x approaches negative half, x minus 2x minus 5. Then this will give us the limit as x approaches negative half minus x minus 5. And that will give us the limit of minus x as x approaches negative half minus the limit of 5 as x approaches negative half. And this will give me minus half minus the limit of a constant is a constant, so I'll write a 5. And this will give me half minus 5, and that is negative 9 on 2. Or 5 times 2 times minus 5 is minus 10. So this is the same as minus 10 plus 1 divided by 2. That is negative 9 out of 2 as the final answer. Wow. Okay. Now let's look at the next example. Here we are going to consider the limit as x approaches 5, square root of 3x squared minus plus 4. So this is the same as the limit as x approaches 5, 3x squared plus 4, all under the square root. So we take the limit of x times 3 all squared as x approaches 5 plus the limit of 4 as x approaches 5. This is the same as the square root of 3 times 5 squared plus the limit of a constant is a constant. So we write here 4. So this is the same as the square root of 5 squared is 25 times 3. So we take 3 times 25, 75 plus 4, that is 79 under the square root. And root of 79 is 8.8882. 1, 2, 3, 4, 1, 2, 3, 4, 5 significant figures. Very simple as that. Very simple as that. Now, I think you solve the last example and then you go. So we look at the limits as h approaches 5, 3, 8, keep minus 2, 8 squared plus 1 divided by 3 versus the limit as h approaches 9, 8 minus 9. So look at this one first. The limit of the quotient is the quotient of the limit. Here is h minus 3. So we take the limit as h approaches 5, 3h cube minus 2h squared plus 1 divided by the limit as h approaches 5, h minus 3. So this one will give us 3 times the limit of h as h approaches 5, all cube minus 2 times the limit of h as h approaches 5, all squared plus the limit of 1 as h approaches 5 divided by the limit of h as h approaches 5 minus the limit of 3 as h approaches 5. So this will give us 3 times 5 cube minus 2 times 5 squared plus the limit of a constant is a constant. So the limit of 1 as h approaches 5 is the same 1 divided by 5 minus 3. The limit of a constant is a constant. So the limit of 3 as h approaches 5 is the same 3. So let's use the calculator. I'm going to have 5 cube, that is 125. So this will give us 3 times 125 minus 2 times 25 plus 1, all divided by 2. So that is minus 50 plus 1. So we have 3 times 125, that is 375. That is 375 minus 50 plus 1 divided by 2. That will give us 326 divided by 2, and that is 163 as the answer. And then if we look at this one, we take the limit of h as h approaches 9 minus the limit of 9 as h approaches 9. So here we're going to have 9 minus 9, and that is 0. Wow, very, very simple as that, and that is 0. So these are the last two examples. In fact, let's start the last one. If we take the limit as a approaches 0, as h approaches 3, we take the limit as a approaches 3, we take a minus 3 divided by a plus 3. That will give us 3 minus 3 divided by 3 plus 3, and that is 0 divided by 6, that is 0. Wow. Then the last example again, you take the limit as m approaches 2, m minus 2 divided by, m plus 2 divided by m minus 2. That will give us that will give us 2 plus 2 on 2 minus 2. That will give us 4 divided by 0, and that is undefined. But division by 0 is undefined. So in our next lesson, we will look at how to evaluate such limits if we come across it. But for now, we will look at this limit as being undefined. We will not proceed because we've not done it to any place. So in our next videos, we'll look at the answer for this limit. But for now, division by 0 is undefined. Thank you for watching, and please subscribe to my channel. Bye bye.